let's see if we can't get to the bottom of what this question 2 is about. Well, straight away it tells us this question's about acidic solutions. The acid dissociation constant Ka for ethanoic acid is given by the expression, so that's good to know. Ka for ethanoic acid is 1.74 times 10 to the minus 5 mole per decimeter cubed at 25 degrees. So at a particular temperature, that's fine because we know temperature can affect the equilibrium constant. A buffer solution with pH 3.87. Now, whenever I read pH, I know that I've got that as well because it's very easy to calculate hydrogen ion concentration from pH. So a buffer solution with pH 3.87 was prepared using ethanoic acid and sodium ethanoate. So good, we've got a weak acid and the salt of a weak acid. In the buffer solution, concentration of ethanoate ions was 0.136 mole per decimeter cubed. So essentially that's our concentration of salt, isn't it, really? That's the concentration of ethanoate ions. Calculate the concentration of the ethanoic acid in the buffer solution. Give your answer to 3 significant figures. So we need a calculation here. So I reckon this is just a rearrangement of the Ka expression. I would also say that we can use pH to find hydrogen ion concentration, like so. And if we can find hydrogen ion concentration, we've got Ka, we've got the salt concentration. So yeah, we should be in here for 3 marks. So over the page, we have got 2.2. In a different buffer solution, the concentration of ethanoic acid was 0.26 moles per decimeter cubed. So that's the concentration of ethanoic acid. And the concentration of ethanoate ions was 0.121. So in 2 different concentrations there. A 7 times 10 to the minus 3 mole sample of sodium hydroxide, so a number of moles, was added to 500 centimeter cubed of this buffer solution. Okay, so we've got a number of moles of sodium hydroxide and no volume or anything like that, but it's 500 centimeter cubed of this buffer solution. Calculate the pH of the buffer solution after the sodium hydroxide was added. Give our answer to 2 decimal places. So calculate the pH of the buffer solution after the sodium hydroxide was added. Well, we don't need volumes really here because we're not looking to, it's not changing in any way. They've not given us the volume of the sodium hydroxide, so there's no new volume here that we need to calculate. But again, this is going to be down to our Ka expression, isn't it? Okay, so we look at our Ka expression, but the thing is, we've got a new concentration of hydrogen ions, haven't we? Because the sodium hydroxide basically neutralizes H plus ions. So what's going to happen? What's going to change there? And for 6 marks, we've got a bit of donkey work to do here. So Ka expression, look at the number of moles of sodium hydroxide. Look at the number of moles of acid that we've got. And what happens when it comes to neutralization, how much acid is left over, and we've got a new kind of concentration of hydrogen ions then, haven't we? Of course, we've still got the same Ka, so we know Ka as well. So yes, we've got some work to do here for 6 marks, but it doesn't look too scary. It's just this manipulation of Ka and the mixtures you have for different buffers and things like that. So it's a really good exercise this in understanding how buffer solutions work and the reactions that go with them. So yeah, all about acids and bases. It says acidic solutions, but yeah, it's an acids and bases question this. So 9 marks. We'll see how we get on.